Okay. Integrate sine 2x. Is it obvious to us? We all know integrate sine x is negative cosine x. But now there is a 2. What happens? If it's not obvious, can I have attention? Look up. If it's not obvious, you may want to do differentiation to help you. For example, do we know how to differentiate cosine 2x? Cosine 2x is minus sine 2x times a 2. Correct? So when we integrate sine 2x, there must be a half. Follow what I'm saying? Okay. So there must be a negative half cosine 2x. Because of this idea. Can? Follow? Okay, let's do example 9b. Tangent square x. I refer all of, so whenever you see an integration question, you look at this page. You ask yourself, I know how to integrate tangent x, given in the formula list. But I don't know how to integrate tangent square. What do we do? Correct? And you search your memory, because some formulas are not here, some are inside here. For example, integrate cosine, you get sine. Integrate sine, you get negative cosine. Integrate secant square, you get tangent x. All these are not in the formula list. But you, in your mind, you have a few formula. A formula list, you have a few. Match them. Try and see what can you do. So now what? Tangent square. We will want to change it to something that is a bit more integrable, which is, no? Any clue? Do we know how to integrate secant square? So how is tangent square related to secant square? Done. It is the same. Can we say that tangent square is secant square x minus 1 dx? Can or cannot? Tangent square is secant square minus 1. So now, do we know how to integrate secant square? Yes. Do we know how to integrate 1? Yes. Done. Can? C. Actually, when you see this question, you may not want to look at a formula list, because formula list won't help you here. Because whatever you can see there, you know how to differentiate and integrate just from memory. No problem. Because you know differentiate sine, you get cosine, etc., etc. So no need, formulas won't help you. So how? Can integrate or not? Can. Can, because think about it. If this is fx, what is f prime x? If this is fx, what is f prime x? If the denominator is fx, what is f prime x? It's actually 2 cosine x. So if your numerator is a 2 cosine x, my job is done. Can we make the 2 appear? Yes. We make the 2 appear. So are these 2 equal? Yup. Sure? No. There must be a half. Can? So now what is this? This is of the form integrate f prime x over fx equals to ln mod fx. Let's see. I'm going to recall. Okay, you recall f prime x over fx. Okay, f prime x over fx. Then done. Okay, what about this next one, D? The tricky part to this question is there's a coefficient A. Now let us look at formula list. We actually know how to integrate cotangent x here. It's ln mod sine x. So which means, can we interpret it like that? Can we interpret from the formula list that if I differentiate ln mod sine x, this is actually equals to cotangent x? Correct? We can interpret it like that. Now, how can I make the ax appear? What happens if I differentiate ln sine ax? Am I right to say that if I differentiate ln mod sine ax, I will get a cotangent ax? Am I right? Yes? Obvious? Therefore, if I integrate this, I will get back this. So if I integrate cotangent ax, I'll get 1 over a times this. Correct? Do you follow? So therefore, I'm going to write it a bit slightly long-winded way, but I hope you understand. I get 1 over a, because if I integrate this, I'll get back this. Correct? I'll integrate this whole thing, I actually get back this. Fine? So that explains why your final answer there is a 1 over a. Can? Zoom in. Okay. Can?